The video is going to be on the remainder and factor theorems. So with that being said, I think the remainder theorem is a little bit easier to understand when we're dealing with just numbers and not actual polynomials or variables. For instance, let's say I had 97 divided by 5. I go through my long division process. And I know that my answer is, let's say for instance, though we aren't using our decimal. Technically our answer is 19.4, yes. But let's say that I didn't have the decimal option. Okay, I have a remainder here of 2. So we know that 97 equals 5 times 19 plus 2. Well, our remainder theorem is actually very similar to that when we're working with our polynomials. So it's our dividend equals our quotient, which actually our quotient is 19, but I use the divisor first. So our divisor times our quotient plus that remainder at the end. Okay, so we're going to look at this a little bit more in depth when we actually use synthetic division, okay? So for instance, let's say that I have f of x, we're working with functions, is x to the 4th minus 6x cubed plus 8x squared plus 5x plus 13. And my goal here is to find f of 4. Now, there are, like I was saying, you are going to be figuring out f of 4. And there are 2 different ways that you can set this up to find your remainder. You can either plug in the 4 into your expression there and see what it calculates, or you can use synthetic division. I'm going to show you both methods. The first method is actually called synthetic substitution because we're using synthetic division, which we talked about on Friday on how to do this. Okay, so with synthetic substitution, 4 here, the f of 4, that's going to be my division, or what's on the outside. And I'm going to set this up as 1, -6, 8, 5, and 13. So I go through and do my synthetic division. I know I'm going to drop down the 1 and keep going from there. Looking at this, I know I have a remainder of 33. The other one is direct substitution. So I just plug the 4 into the x spot. And by the time I plug all of that into my calculator, I will see that f of 4 is 33. Notice here, my remainders are the same. However, the nice thing about the synthetic substitution is then I can see what my polynomial is for my remainder theorem. Whereas with the direct substitution, I can't see that. So if I wanted to write my remainder theorem, I have my divisor, not my divisor, my dividend equals the quotient times the divisor plus the remainder. So if you're asked to set this up in this form, this is what you do. You'll have to use your synthetic division. So my dividend, that's all the way at the top. That's the x to the fourth minus 6x cubed plus 8x squared plus 5x plus 13. Okay. So x to the fourth minus 6x cubed plus 8x squared plus 5x plus 13 equals, well, what's my quotient? That's where this synthetic division comes in handy. So I've got x cubed minus 2x squared plus 5. What's my divisor? My divisor was that 4, which means that it's going to be x minus 4. Plus, well, what's my remainder? My remainder was 33. Okay, so this would be your remainder theorem, what they would want you to write out. Your dividend equals your quotient times your divisor plus the remainder. Okay. Here is where the factor theorem comes into play. So I know that x minus a, I'm dividing by x minus a. If x minus a is, when it's divided, if x minus a is divided by the polynomial, and so if x minus a is the divisor of the dividend and has a remainder of 0, then it is a true factor. Okay, so there are a couple different ways that we can do this. You can either use synthetic division or long division. Majority of you are probably going to use synthetic. So let's say that I'm asked to figure out whether or not x minus 2 is a factor. If yes, find the remaining factors. The remaining, sorry, there's no D in remaining. What I'm going to do, first of all, I have to figure out whether it's a factor or not. So I'm going to use my synthetic division to figure out if my remainder is 0. If yes, then I can proceed on to find the remaining factors. So I know it goes in, well, goes in or comes out opposite. So it's positive 2, 1, 7 to negative 40. Drop down the 1. Looking at this, I get a remainder of 0. What does this mean? This means so far that I have x minus 2 times x squared plus 9x plus 20. So yes, it was a factor, but now I need to find the remaining factors. Well, obviously this one's a factor. We already determined that. So this is where, when we were factoring polynomials, this is where that comes into play. So you're going to factor this. You can do it a couple different ways. You can graph it. You can use the quadratic program. You can factor it using special cases, or you can factor it using AC. Okay, so the option is up to you. I'm going to factor it using AC, just because I know we're going to need a refresher. And not always will it come out to be a nice number. So for instance, if you're using your quad program, it might come out as no solution. We'll talk about that later on. So looking at this, I know that I have a factor of x plus 4 and x plus 5 as well. These right here are my remaining factors. Okay, so there's no remainder. I know I'm cutting it close to my 15-minute time limit, but I want you guys to work on this. So I'm going to give you another problem, and I want you to figure out the other factors based on it. And I've got x minus 1. All right, so I've got my polynomial of x cubed minus 3x plus 2. I want to figure out whether x minus 1 is a factor. If yes, go ahead and calculate the other factors. I'll give you a hint. Make sure you have every possible exponent when you're doing your synthetic division. Good luck. Looking at this example, I'm going to go ahead and do my synthetic division. It's a -1, so it's going to be a positive. I've got 1, 0, -3, and 2. And I see here that I have a remainder of 0. So I have x squared plus 1x minus 2. Using your quadratic program, it goes in opposite of what you see it. So it's x minus 1 times x minus 1 times x plus 2. Final answer.